So you should expect similar questions in your exams. So some people are making some minor, very minor errors. Please try to avoid them. So try to avoid them. So like even question number 1, that was very simple, but some people are making very minor mistakes. What is it?
Riley?
What is your name?
Bryson Minton.
What's your name?
Parker. Is there any particular spot you'd like?
What?
Is there any particular spot you'd like me?
No, I mean, did you do a quiz?
Sorry? Oh, no, I transferred in.
I have to give my quiz today.
Okay, come forward. All right, let's start. So let's start from section number 3.2. Section 3.2 C. Section 3.2 C. So use slopes to identify the parallel and perpendicular lines. So let's start from the parallel lines. So two lines that have the same slope are called parallel lines. Parallel lines have the same steepness and never interact or intersect. Two lines that have the same slope and different y-intercepts are called parallel lines. So two lines that have the same slope and different y-intercept are parallel lines. Parallel vertical lines have different x-intercepts. So you can have the lines on them. When you use the slope intercept form. So if you have the same gradient for the slope and a different y-intercept, it can give you parallel lines. You can also have lines on the y-axis, which are parallel, and also on the x-axis, which are parallel. So example number 1, use slopes and y-intercept to determine if the lines are parallel. So 3x minus 2y equals to 6, y equals to 3 over 2x plus 1. So to check whether these are parallel lines, then we use the y-intercept. So for this, then 3x minus 2y equals to 6, and y equals to 3 over 2x plus 1. So those are the two lines. So to check whether they have the same gradient, then you write this one in the slope form, which we wrote last week, where you can write this in the form y equals to mx plus c. And this one is the slope. And this one is the y-intercept. When x equals to 0. Y-intercept when x equals to 0. So if this is different and this one is the same, if the gradient for the two lines are the same, then we have the parallel lines. So let's check whether, so here our gradient is this one because we have already written in the form y equals to mx plus c. So we already have the gradient in the second equation there. Then we look for the gradient in the first equation. So we write in this form y equals to mx plus c. So here 3x minus 2y equals to 6. So we make y the subject. So you make y the subject. So you take 3x to the other side, or you minus 3x here. So it will be 3x minus 2y equals to 6 minus 3x. So minus 2y equals to 6 minus 3x. Then you divide by minus 2x. So when you divide this one minus 2, you divide by minus 2 over minus 2 over minus 2x. So y equals to minus what? 3 plus 3 over 2x. So you can write this as y equals to 3 over 2x minus 3. So that is our first equation, which is this. And then the second one, so this is the first. The second one is that one up there, y equals to 3 over 2x plus 1. So this is our second. Now, from here, what can we see?
Same slope.
So we have the same slope, right? We have the same gradient, which is 3 over 2. And then we have different one, y-intercept. So here now, y equals to 3 over 2x minus 3. So when x equals to 0, then y equals to minus what? Minus 3. So our point here will now be what? 0 and minus 3. Then this other one will be y equals to 3 over 2x plus 1. When x equals to 0, then y equals to what? 1. So our point here will be 0 and 1. 0 and 1. So we can identify these ones as parallel lines. They have the same gradient, but they have different y-intercepts. Okay? All right. Okay, try this. Try y equals to 2x. Y equals to 2x minus 3. And minus 6x plus 3y equals to 9. Check whether it will give you different y-intercepts. So the first one, m equals to 2, okay? So m equals to 2. So check whether the second one, the gradient or the slope will be 2. So here you take minus 6 to the other side. So it will be 3y equals to minus 9 plus what? Plus 6. Then you divide everywhere by 3. So y equals to minus 3 plus what? Plus 2x. So do we have the same gradient? So m is equals to 2. And we have different y-intercepts. So the first one, the y-intercept here will be what? 0 and 1? Negative 3. And this other one will be what? 0 and also negative 3. Okay, let's come to the next. Use the slopes and the y-intercept to determine if the lines are parallel.
I have a quick question. I thought that one of the previous rules on the page you showed us first said that the y-intercepts had to be different for it to be parallel.
Yeah, that's what I'm trying to check. I will come back to that. Okay. Yeah, there is something I want to confirm from there. Because we say the y-intercepts should be the same. It should be different, but this one, they're the same. So it's giving us something else which we'll discuss. All right, so use the slopes and the y-intercept to determine if the lines are parallel. So y equals to minus 4 and the y equals to 3. So here we have y equals to minus 4 and also we have y equals to 3. Y equals to minus 4, y equals to 3. So the first one, this is a line, right? So this is a line like this. So this is the line at the point Y. This is the line at the point Y equals to -4. That is a line where Y equals to -4. So it is an horizontal line, and this case, if it is an horizontal line, then we say if it is an horizontal line, the slope is what? 0. So the slope is 0. So therefore, in this case, the y-intercept is what?
The y-intercept?
Yeah.
-4 right there.
Yeah. So x is 0 here, then the y-intercept is what? -4. So our point is 0 and -4. So this is the y-intercept. Now, the next one also, y equals to 3. So the slope is what?
0.
0. So the y-intercept is 0 and 3. So that means this one is a what? A parallel line. So it is a parallel line. So again, if x equals to -2 and x equals to -5. If x equals to -2 and x equals to -5. So when x is -2, so when x is -2, this one is a graph. So when x is -2, so -2 is somewhere there. So that means this line will be what? Like that, right? And also when x is -5, when x is -5, then it will be somewhere there. So definitely our gradient is said if it's a vertical line, then the gradient is what? What did you say about the gradient? When it is vertical, it is what? We say it is undefined, right? Because there is no change in what? There is no change in what? X. Because we say for m equals to change in y, all over change in x. Okay? And then so this change in x is 0. So when you divide anything by 0, you're getting what? Undefined, not 0. You cannot define it. You cannot even get it in your calculator. When you divide 2 by 0, you cannot define it. But if it is 0 all over 2, then this one is equals to 0. That is the same as 0. But if it is like 2 all over 0, then this is undefined. So definitely, if you have x equals to -2 and x is equals to -5, both of them, the gradients are different. The gradients are undefined, sorry. And now those are the lines which are parallel to one another because one is in -2 and another one is in -5. Okay? Okay, so quickly let's come to perpendicular lines. Perpendicular lines. So for the perpendicular lines, this is two lines which are perpendicular to one another. Okay, so So these are lines which are crossing one another on a right angle triangle. So they are perpendicular to one another. So here, for a perpendicular line, the product of the two gradients, M1 and M2, is equals to -1. For a perpendicular line, then the two gradients, the multiplication of the two gradients is equals to -1. Is equals to -1. So the vertical lines and the horizontal lines are always perpendicular to one another. The vertical lines and horizontal lines are always perpendicular to each other. So example number 1. Y equals to -5x minus 4 y equals to -5x minus 4 and minus 5y equals to -x plus 1. So y equals to -5x minus 4 and x minus 5y equals to 5. So the first one we have here m equals to -1, -5. So we can get m in the next equation here. So we take x to the other side. So -5y equals to 5 minus x. Then you divide by what? 5 minus 5. So -5 over -5 and then over -5. So y equals to -1 plus what? X over 5. So y is the same as x all over 5 minus 1. So our gradient here is, so I noticed something with some of you here. What is 20 over 5? 4. What is 20 over 4?
5.
So some of you don't know what is 20 over 5, what is 20 over 4. You can still use your calculator, right, to get it. Yeah, so please avoid very minor arithmetic errors like those. I will reduce your marks if you make such a mistake, okay? So you might get less than 1 or something like that. So here, m equals to 1 over m equals to 1 over m. So we say, so this is, let's say this one is m1 and this one is m2. So m1, check whether m1 and m2 equals to -1. So m1 is -5, m2 is 1 over 5. This one is equals to, so this and that will cancel. 1 minus 1 times 1 is equals to -1. So therefore, this line is what? Perpendicular. So this one is a perpendicular line. So we say the perpendicular line M1, M2 equals to -1. M1, M2 equals to -1. Is that clear? Am I doing very fast? Anyone with any question? try this one. 7x plus 2y equals to 3, and 2x plus 7y equals to 5. 7x plus 2y equals 3, and 2x plus 7y equals to 5. So here you make y the subject, or you take 7x to the other side. So 2y equals to 3 minus 7x. So y equals to 3 over 2 minus 7 over 2x. So this is the same as y equals to minus 7 over 2x plus 3 all over 2. Okay? So the next one, you take 2x the other side. So 7y equals to 5 minus 2x. So you divide by 7. So divide by 7, 7 all over 7 there. So y equals to 5 all over 7 minus 2 over 7x. So this is the same as y equals to minus 2 over 7x plus 5 all over 7. So m1 is equals to minus 1, 7 over 2, right? And then m2 equals to minus 2 over 7. So is this giving us a perpendicular line? No, because m1, m2 is not equals to minus 1. So here, m1, m2 is equals to 1. Because when you divide, when you multiply negative and a negative, you get a positive. So that is not giving us a perpendicular line. All right. So this one was for last week. Now let's come to this week. The equation of a line. The equation of a line. Section. Any question up to there? So let's come to section 3.3. 3.3. Equation of a line. So we can easily determine the slope and the intercept of a line if the equation is written in slope intercept form, y equals to mx plus b. Y equals to mx plus b. So if you're given a graph like this, like that, then you're told to write the equation of that line. Write the equation of that line. So here, you identify that one of the points, you can identify a point there. So we can identify this point over here. So here, our x is what? 5. And our y is what? Negative. Then also, we can identify the y-intercept. So where is the y-intercept? So y-intercept is where x is equal to what? 0. So this point here, that is our y-intercept. So it will be 0 and 1. 0, 1. So our equation here is y equals to mx plus c. So we now know c is what? C is 1. So we have c as 1. Now we look for the unknown, which is what? Which is m. So we now look for m. So m equals to change in y all over change in x, where we say this is the same as y2 minus y1 all over x2 minus x1. So we already have 2 points there. So we have 0, 1, and we also have what? 5 and negative 4. So you can easily get the gradient. So this is equals to, so we can take this one as x2, y2. And then we take this one as x1, y1, like that. So y2 minus y1 is, so minus 4 minus 1, right? Are you seeing that? All over, change in x is 5 minus 0. So our gradient is equals to minus 4 minus 1 is what? Minus 4 minus 1.
-5 over 5.
So negative 5 all over 5. And this one is equals to negative 1. Yeah. So we now have m is equals to minus 1. So what is our equation of the line? So y will now be equals to minus x plus 1 plus 1. So that is the equation of that line. Are we together? Okay. So we can have another one here. What is the equation of that line? What is the equation of that line? So we use the same procedure. You get the y-intercept. So the y-intercept here is 0 and what? 0 and 1. Then you can identify any other point on the line. You identify any other point on the line. So I took this point here. And this point is minus 3 and minus 1. Minus 3, minus 1. So we have the y-intercept, and then we have the 2 points there. So we can get the change in y and over the change in x. So our equation is y equals to mx plus c. So we have this one already as 1. So we are looking for this. And this m equals to change in y all over change in x. So we get this as, let's say this one is x1, y1, and we take this one as x2, y2. So now, let's now look for the change in y over the change in x. So, and here will now be equals to change in y. So y2 is minus 1. y1 is minus 1 all over. X2 is minus 3 minus x1 is 0. And this one will give us what? Minus 2 over 1? Minus 3. So m equals to 2 over 3. So our equation of the line will be what? Y equals 2 over 3x plus 1. Is that clear? All right. So let's come to find an equation of the line given a slope and equation of the line given the slope and the pole. So you're given a slope and then you're given 1 point. So what will be the equation of that? So suppose we have a line that has a slope m and that contains some specific point x1, y1, and some other point, which we will just call x, y. So I gave you this one in your exam, right? In your quiz, where I told you to make x the subject. Some of you are failing. So in our quiz, I said y equals to y minus y1 equals m x minus x1, and then I say make x the subject. So here you divide everywhere by what? M first. So y minus y1 all over m equals to x minus x1. So make x the subject, that means you bring this one to the other side. So y minus y1 all over m plus what? Plus x1 equals to, some of you are dividing everywhere that m up to x1. But some of you are doing well. You are writing here m, and then they divide this one by m there. That is correct. But now, if you divide by without putting the m there, then that one is very wrong. Okay, so so we have here m equals to y minus y1 all over minus x1. So y minus y1 equals to m x minus x1. So you can be so here you're given a point x1, y1 there, and then you're given the gradient which is m. And then you're told to look for the equation of the line. So you take another point which is x, y, and then you use that point which you're given there, and then you also use m, and then you use this equation here, or you use this one over here. Okay. So example number 1. Find the equation of a line with the slope m. So you're given the slope m equals to 1, and it contains the point 7 and 6 there. So you're given M, and then you're given a point there, 7 and then 6. Then you're told to find the equation of that line. Find the equation of the line. So this is the point x1, y1. So you take another point, which is x, y, to form the equation of the line. Form the equation of the line. So M here will now be y minus y1 all over x minus x1. Okay? Or you can use y minus y1 equals m x minus x1. So y minus y1 here is what? 6. y1 is 6 equals to m is what? 1. And then x minus x1 is what?
7.
x1 is 7. So y minus 6 equals to x minus 7. So y equals to x minus 7 plus what? Plus 6. So when you'll be doing your homework, I know this is what your Newton is accepting. This one. But you can, I don't know whether if you simplify and then you write the answer, I don't know. I think this one is what is accepted. This is still the correct answer, but you need to write in the exam, you write in this form, y equals to mx plus c, okay? So you simplify further this. So this is equals to y equals x minus 7 plus what? Plus 6. So y equals to x minus 7 plus 6 is minus 7, you're in minus 7, and then you go 6 steps forward. What is that? Negative 1. So this is our equation of the line. So another example. You have m equals to minus 1 over 4, and then you have the point minus 8 minus 2. So what is the equation of that line? What is the equation of the line? So using the same formula, y minus y1 equals m x minus x1. So this is so x1, this one is y1. So y minus minus 2 equals to m minus 1 all over 4 x minus minus 8. So y minus minus 2 is y plus 2 equals to minus 1 over 4 x plus 8. So y equals to minus 1 over 4 x plus 8, and then minus 2. This one is what our Newton is saying, but you can simplify this one further. So y equals to multiply by minus 1 over 4 inside here. So you get minus 1 over 4x minus 8 over 4 plus what? plus 2b. So y equals to minus 1 over 4x minus 2 plus 2. So finally, what is our answer?
Y equals 1 over 4x.
Yeah. So y equals to what? Minus 1 over 4 x. Okay. So you can be given another point here. Find the equation of the line that contains the points minus 5 over minus 5, 8, and 7 minus 2. So you're given the points there, then you're told to find the equation of the line. So where should you start from? Where should you start from? So you start by getting the what? M, right? So M equals to change in y over change in x. So you can take this one as x1, y1, and take this one as x2, y2. Yeah. So M equals to y2 minus y1 is minus 2 minus 8 all over 7 minus 5. So M equals to minus 2 minus 8 is negative 10 all over 7 minus 5 is plus what? 12. And this one is equals to minus 5 over what? Minus 5 all over 6. So that is M. Now, to get the equation of the line here, then we take another pole, which is what? X and what? And y. And take the x1 and y. And take the x1 and y1. And then we definitely have M equals to minus 5 over 6. Now use this. Y minus y1 equals to M x minus x1. So y minus y1 here is 8 equals to M is minus 5 all over 6 x minus x1 minus 5. There. So y minus 8 equals to minus 5 all over 6 x plus 5. So y equals to minus 5 over 6 x plus 5 plus what? Plus 8. Then you simplify. Is that clear? Any question? Any question? So you go and read. So we will be doing our quiz again on Friday. Okay? So it will be covering chapter 3 on Friday. All right, see you.
I have my quiz. I never got it.
Oh, what is your name?
Abby? Thank you.
Good night.
on the quiz because I had to email it to you.
Oh, you are,
Destiny.
you did not write your name, right?
Oh, no, sorry.
Yeah, so I think it's,
Yes, that's it. Thank you so much.
all right.